This is Max Gravett of Digital Scarcity. The purpose of this video is to review the Harbor R token standard on Ethereum and also do a quick tour of what security tokens could be if implemented on EOS. So on the screen now I'm showing the R token repository, GitHub repository. You can see that it's made up of really three files. The migrations file is just part of the build process, and the test files are just that, just sort of example implementations. And if you look at the three files here, these are the three smart contracts that represent the R token standard. So the first bit here is the regulated token. This is the one that actually implements ERC20, as you can see here. And what it has is an ability to connect to the R token service. See here, it is able to return a regulator service based on the registry, which is a member. It's a member of the contract. So each instance of this contract is going to have its own service registry. So let's take a look at the service registry. This is simply a list. It maintains a list of services. So it should have a member in here that is the, let's see, the list of services. Oh, it replaces its service here. So it just allows the user to replace the service that it holds. And then then you have your service itself, your regulator service, and it is incredibly straightforward. It just has a check method. So what this does is it allows the token, if you implement the token interface, it allows the token developer to place these checks inside various events such as transfers or mint or issue, the various actions and functions that occur as part of the token management process. So you pass it all of the data that you have about the token itself, the spender, the from, the add, the to, and the amount, and it'll run. This is just the interface here, but whoever implements it will be able to run their business logic that says check the amount, check to make sure that the to address has been KYC approved, check to make sure that the from address is no longer in their lockup period, etc., etc. So it's really just a series of these three interfaces that work together to create a pattern that allow business rules to be put into ERC20 tokens. And my opinion, as I kind of looked at this, I've implemented this standard before, and it works. I don't know how much innovation is taking place in this space. I mean, I think Ethereum is a bit dated. It's running into a lot of scalability issues. You can see here that even in this repository, it hasn't been, updated since February 9th, February 1st for some of these other guys. So, there's not a lot of innovation going on with this standard, but it does work. What I don't know is if there are any other ecosystem components, such as an exchange that is supporting this standard. I haven't seen anything. But I do know that Harbor has raised a lot of money in 2017 when there was the gold rush towards ICOs. So it has a bit of a war chest. So it's something to keep our eye on and see what takes place. So I wanted to just show you that at the beginning of this video, and I wanted to go through we'll do EOS. I wanted to talk about EOS a little bit. EOS does not have a parallel to that standard. It is, if you think about Ethereum came out in 2012, and then the R token standard came out in maybe 2016. Polymath has a very similar token. So it took several years for Ethereum to the community around Ethereum to develop a security token standard. I don't think it'll take nearly that long in EOS. EOS has only been around for 2 or 3 months. I think most people know there obviously needs to be a security token standard. Nobody's done it yet. I think it's just a matter of some leaders in the community getting together and establishing what that standard should be. And then we can begin implementing tools in the ecosystem that work with that standard. But independent of that, anyone could create a decentralized exchange that was able to work with EOS tokens that implemented the standard. Because even if those standards were implemented in a core base EOS token, it would still work with existing exchanges, because it would block off transfers or issues or other events occurring on that token based on the business logic embedded with that token. So anyway, long story short, nobody's quite done the legwork to develop the standard on EOS, although it's a massive opportunity for whoever comes first to market. I would love to partner with someone who has the appropriate business background in securities, appropriate licensing, regulatory chops to be able to launch something like this, because the technology is something I certainly have a hold on. Okay, so let me talk through a little bit about same thing that I showed you in Ethereum, I'll show you now in EOS. So EOS, instead of Solidity, it's C++, so it looks just a little bit different, but it's still pretty straightforward. Here are the data structures within the smart contract. So we'll start here with the accounts table. So the accounts table just holds a balance, and it has the primary key, although you can't see it here, is based off of the scope. The scope is based off the actual account itself. So I'll show you this in action in a little bit, but there's the takeaway is there's a data structure inside the smart contract that keeps track of balances, just as you'd find on ERC20 tokens. There's also a data structure that takes care of the symbols themselves. So it has some additional pieces in here that keeps track of the supply of each token. That's how much has been issued or minted. Then there's the max supply, so that anyone creating the token can specify the maximum that can ever be issued of that token. And of course, just like with Ethereum, there's an issuer, and that's the person that has permission to issue the tokens out of the reserve out into the ecosystem. That information, those tables are base tables that come with the EOSIO token that is launched by Block 1, which is core to the ecosystem. What I've done in this smart contract is I've added just a couple thin additional layers of business logic that capture some of the things I know about regulated tokens. So I've added in an address book, so also known as a whitelist of people that can be placed inside this address book when they are approved to receive a token. So what will happen when the ecosystem, someone tries to transfer this token to an account, it'll check to make sure they're in this address book. And if they're not, it'll fail the transfer and back everything out to how it looked before the transfer was attempted. I've also added in a KYC Approver, the sense of KYC Approve, so that the person has to be in the address book, and they have to be KYC approved. And my understanding of that is that it's a two-step process, that somebody, if they're in the right jurisdiction, they can be approved to receive that token, but then it's a secondary step for a third party to, or I guess the issuer can do it themselves, I'm not sure, to check the person's documentation and credentials and then provide their stamp of approval that this person is who they say they are, and we can report the appropriate information to the authorities as if we need to. I've also added in the notion of lockup expiration. Lockup expiration would be, once they are initially issued or transferred the token, then they would have, a certain amount of time before they could transfer that token to someone else. I'm not a guru on the matter. My understanding is that's one part of the regulations that are on these guys. Okay, and the other piece that I added up here, this is a table, very simple, just a list. It's just a list of accounts that this token administrator has granted authority to be KYC approvers. And the reason I did this is because just in my limited experience with the actual security industry, is that lots of times third parties are the ones that perform the KYC process. You can hire third parties that just specialize in KYC, and you outsource. If you're the financial component or the issuer, you would outsource the KYC pieces to a third party, and I think that helps the issuers not have to become gurus in KYC, and also there's probably some sense of liability there that if something does go sideways, they can say, well, we used this third party and they were well regarded in the industry, so let's talk to them about it. Okay, so that's all the data structure. So let me jump over to the implementation of some of these functions, and I'll put this to use pretty quickly. So I'll glance through this. I know it's probably pretty dry to look at this code here, but let's take a look at the transfer method. This is what transfers tokens from an account to another account, and it transfers this quantity with a simple memo field. So the first thing this does is it will open up the address book. It will look for the to account, and if it does not find the to account, it will assert out a failure. So what that does is it halts the transaction and rolls everything back to the state it was before the transaction was started. And with an error message, recipient has not been whitelisted. So that is just a message that would print out. And we'll take a look at this in a second. Then it checks to make sure there is a KYC approver in that account record, and if not, it asserts out again. Recipient has not been KYC approved. Then it does another check. We talked about the lockup expiration. It gets the current timestamp, as in right now, that's as of the time the transaction is occurring, and checks to make sure that right now is greater than or equal to the lockup expiration. So if it's before the lockup expiration, this condition will become false, and it will assert out and to give you the error message, the sender is still in the lockup period. So this is the logic that implements all of those rules that I talked about, and you can see it's here in 12 lines inside of the smart contract. It would be pretty trivial to add additional logic in here, talking about the maximum transfer quantity, or you wanted to save the jurisdiction where that recipient is a citizen, and make sure the token has an associated list of jurisdictions, and let's make sure that recipient is is authorized to receive that token. What I don't know, and I'd love to partner with someone who does, is what are the list of all the business rules that need to be accounted for in security tokens. And I could build all of those business rules inside a smart contract and allow for those security tokens to be configured based off of the parameters of that certain security. Okay, so that's essentially the software. It comes with these couple files in here. These other ones are just sort of ancillary compiled files. The CPP and the HPP file are really the ones that hold all the logic. So what I'm going to do now is just run some of this stuff. Let me try to make this a little bigger. So I'm going to have our stuff running in Docker, so I'm going to bring it all down first. This is my EOS environment. I'm just going to bring it down, and I'm going to bring it back up so that it is a brand new chain with no accounts created and no contracts deployed. Okay, now that's up. I have stored in my IDE a list of all of the commands that I'll be running, just because as you'll see, it's a lot. Each command is pretty long and there's a lot of them, so I'm going to do a lot of copy paste here, but I'll explain it as I'm going. You could fast forward through this, it won't hurt my feelings. So this is the command to compile everything, EOS IOCPP. It creates a WASP file, it's a WebAssembly file, and an ABI file, which is the application binary interface. And those files together tell the blockchain everything it needs to execute that logic. So I'm just going to paste that command in here. And just give that a second. Gives me some warnings, and we're good to go. So let's head back. So now everything is compiled. The first thing I'm going to do here is create a bunch of accounts. So this command is Kleos create account. This is the parent account, this is the name of the account, and then followed by the keys. Just because I'm testing here, I have the same keys for every account. You wouldn't want to do this in production, but just makes it simple so I don't have to keep track of 1,000 different keys. So I'm going to create all of these up to here. So I'm going to copy that. Let's go back to here. Paste all of that in, and then I don't have my wallet unlocked, so we'll unlock it. Now we're good. Okay, so now those accounts are created. Now what I'm going to do is I'm going to actually take the contract that I compiled up above, and I'm going to inject it into the token account. This is akin to deploying a contract on Ethereum. When you do it in Ethereum, it actually creates a new account for you and injects that smart contract into that account, into that address. It's a little bit different in EOS. You create an account, and then you can inject the contract smart contract into that account, and then you can continuously upgrade and re-inject that contract into that same account. So let me just paste that, and there we go. So it set the code, and it set the ABI, and now that smart contract is ready to go. Okay, so let's go ahead and get going and actually create some tokens now. So this first step here is going to create a token. It's going to be called XYZ, and it's going to have 1,000,000 XYZs as the maximum supply, and holder 1 is going to be the issuer, meaning that person is going to have the authority to issue that that token. All right, and that's that. So this step here, I am going to, issue to holder 1. He's the issuer. He can issue to himself, and he's going to issue all of them to himself as the initial balance. And that's fine. In this case, you could think of the holder 1 as the security owner or issuer, either the financial institution helping with the security, or it could be the the owner of, if it's a physical asset, the owner of that physical asset, any of those types of parties it could be. All right, so let's now try to transfer to this account holder 2. We're going to transfer 1,000, and here we go. So what we did is we got an assertion failure. It did not allow that to happen. So let's take a look at the logs, and here we go. You can see in the logs, recipient has not been whitelisted. That's the error message there, because we never put holder 2 into the whitelist. So let's go back and take a look. Let's do the next. So let's add the account holder 1 and holder 2 to the address book. And what I'm going to do is when I add this account, I'm going to specify no lockup. No lockup just means there's no lockup period for holder 2. I'll show you the lockup period in a second. Okay, those guys are added. Now what I'm going to do is go back a couple steps back to my transfer. Here, Clio's push action token transfer holder 1 to holder 2. Holder 2 is blocked. You can't really see it here on the screen, but let's see if I can move that. That's, well, just take my word for it. It says holder 2. And now I'm going to do it. Well, let's see what happened there. There we go. So recipient has not been KYC approved. So it checks both of those. You have to be on the address book and you have to be KYC approved. Actually, I was expecting that to work. I forgot about that step. Okay, so now let's add a KYC approver. So this is an account. KYC is the name of an account. We're just going to add that account as an approver. So this would be the administrator, the person that hired the KYC company or third party, and this is where you would add them in, and then they have the authority to approve individual recipients and accounts that account is who they say they are. So add that guy, and then we can come back, and now that account KYC can approve holder 2 as for KYC. So let's take a look at the table really quickly. Let's see. The name of the table here is address book. So we're just going to take a look at the address book. So here's what the data looks like on chain. So we have a couple different accounts. Holder 1, he by default, since he's the issuer, he's already KYC approved. And this is his lockup expiration. So it expired because he had no lockup. It expired as soon as the account was added to the address book. And then holder 2 was no lockup. His account was also added. You can see it's just like 100 milliseconds or so after holder 1. We issued it right after. And he was issued with no lockup, so that has the, like I said, the now expiration. and you see as a KYC approver of the KYC account. We can go back and actually look at that table if you want to. KYC accounts. Okay. Why wasn't that showing up there? Okay, so then we can, hold on, lost my place here. Let me jump back to the steps. Okay, so there we looked at the address book, and now let's try to transfer again from holder 1 to holder 2. So now they've been added to the address book, and they've been KYC approved. And voila, they can now receive the token. So if we look at the, we'll look at the balance for holder 1 and for holder 2. He was initially issued $1 million, now he has 999,000. Holder 2 is transferred 1,000 XYZ, and voila, they have it because they were added to the address book and KYC approved. The last thing I'm going to do is just show you the lockup period. So what I'm going to do, it's going to go pretty quick because I'm going to be in a lockup period. I'm actually going to change this to 1 minute. So we're going to add the account holder 4 with a 1 minute lockup. Then I'm going to approve holder 4 for KYC. Then I'm going to transfer from holder 2 to holder 4. And he should be able to get that because he's been added to the address book and he's been KYC approved. And then what I'm going to do is try to transfer from holder 4 back to holder 2. And what you're going to find, if it's 1 minute, which I'll try to run all these within 1 minute, it'll show you a failure that the holder is still in the lockup period. And then I can show you, we'll just let a minute lapse. That's why I want to change it from 1 minute to 3 minutes, so we're not waiting for too long. And we'll then be able to have it go through. Okay, so we'll do these one at a time. So that created the account in the address book. Cleo's table. There we go. We got holder 4 with a regulation type of 1 minute. Approved him for KYC. Transfer. And we got a failure. Good. So let's take a look. There it is. Sender is still in the lockup period. So what we can do is try it again, and we'll let this go by. It'll be, probably 20 more seconds at this point. I am wrapping up the video, so just in summary, what we've gone through is the security token on Ethereum, the R token standard, which allows the author to develop these business rules that implement a method called check, and then the developer can add those checks into their token. It's really just a framework or a template for adding business logic to your smart contract. And we did the same for EOS. As I mentioned, EOS, it's only been out for 3 months now, so nobody has really built this standard or created a standard yet. I think there's a massive opportunity there, and personally I'm looking for someone to partner with on that opportunity. And I think it'd be pretty straightforward. I don't know if what I've shown here in this token is the final design. It is just an illustration of how easy it is to do business rules. We may want to, just like the R token was designed, break it out into multiple contracts that can be dynamically added into the token. That's something that can be decided later. But okay, I think the minute's gone by. Let's give it a shot now. And perfect, there we go. So you can see that the time clicked down and we got past the lockup expiration period for account holder 4, and they were then able to transfer the token. We can now just check the balances on these accounts, or we'll check the address book and then the accounts themselves. This is just how the data is stored in the smart contract. So we looked at this already. This is the address book. So it contains the account name, the regulation type, which is the lockup type. It could also be the jurisdiction, the country that person's in, or we could add another column in here for jurisdiction. The KYC Approver and the lockup expiration period. And then here it shows the balances of the accounts. So this was the $999,000 for holder 1. Holder 2, he was transferred $1,000, and then he transferred out $5 back to holder 4. I think holder 4 was initially transferred $10, and then he transferred $10 back to holder 2. That's why it's showing $995 and $5. All right, well, thanks for tuning in. This is Max at Digital Scarcity.